Hello, good day everyone. How are you doing? I hope you are doing fine today. So to all my subscribers on this channel, I want to say a very big thank you today. I really appreciate your prayer. I really appreciate your motivation. And this is what has been keeping me going. And if you are new to this YouTube channel or you are just watching my video for the very first time, I want you to click on the subscribe button so you can be notified once educative content like this is dropped on this channel and you are going to be notified. So thank you. So very quickly today we are going to be looking at a concept under numerical analysis called curve fitting. Under this curve fitting, we have about 3 or 4 aspects under this. We have the linear type, we have the non-linear, we have the exponential aspect of it too. So here on this question, they are telling us to determine the regression equation using the non-linear for this equation, which is what? Y equals to a plus bx plus c x squared. Now, for every mathematician, we know that when we have an equation like this, it is a quadratic equation. It is a quadratic equation, and we always tell our students that when you have a quadratic equation, when you plot the graph, it usually looks like a curve. It usually looks like a curve, right? So you now notice that for this question, we have been given the value of x and we have been given the value of y, right? We don't know where this value comes from. Maybe it is a data or it is actually from a function we don't know, but we have been given. Now, what are we going to do? We need a curve. We need a curve that will best fit this data. We need a curve that will best fit in this data. What are we talking about? You know, at this point, we plot this graph now. We plot this graph. Let's assume we have something like this, right? We have all these points located. At the end of the day, you know, this is our fx, which is what? A plus bx plus cx. And we told you that it will look like a curve. You can see this curve is the one that best fits this what data. You can see it maps up to 4 out of those points. You know, when we are plotting graph in physics, in our physics class, and we want to take the gradient, we always find it hard to take gradient sometimes because we are looking for a point, at least 3 points that we what best fit in our data so that we can get our what gradient. Are you get what I'm saying? Same thing is applicable here. So we have been given some constraints, we have been given some equation, which is what? Ey equals to na plus b summation x plus c summation x squared. These three equation, let's call this one, let's call it two, let's call it three. We are going to use them to look for our value of a, our value of b, our value of c. Don't forget that these three values are real values, and when we plug these three values back in our equation y, which is equals to what? A plus bx plus cx squared, we can now have a quadratic curve on our given data, which is what? X and y, right? That will best fit these data that we have. Are you get what I'm saying now? That will best fit in this data that we have. So, which means at the end of the day, I still needed some table. If you can see, we have summation y, we have summation exy, and we have summation x square. For me to have all of this, it means I needed a table, right? So, what this is the question. What are those things I needed on my table? Those things I needed on my table is already embedded here in all my three equations. So, what are those things I needed on my table? I need the value of y, right? I need the value of x. I need the value of xy. I need the value of what? X square. I need the value of x cube. I need the value of x raised to power 4, right? Such that at the end of the day, I can now find the summation of y. Can you see? Summation of x, summation of e, summation of xy, summation of what? X square, summation of x cube, summation of x raised to power 4. And also we need summation of, can you see, x square y. Can you see? So I'm going to plot the table. I'm going to draw my table now and put in those necessary values. I'm going to draw my table now and put in those necessary values. Very good. So this is our table. You notice that on our given table, we have the value of x, we have the value of y. So we need what? The value of xy, we need the value of x square y, we need the value of s square, we need the value of x cube, and we need the value of x raised to power 4. Now, having this, we have 1 and 2. When we multiply 1 and 2 together, we have 2. You can see, when we have 1 raised power 2, that is 1 times 2, it will give us 2, right? When we have 1 times, when we have x squared, which is 1, that is 1 times 1, it will give us 1. When we have 1 times 1 times 1, it will still give us 1. When we have 1 times 1 times 1 times 1, it will still give us 1. So let's move on to the next one. So to save our time, I'm just going to do 2. You can confirm the rest yourself. So we have 3 times 8, it gives us 24. Can you see? 3 squared, that is 9. 9 times 8 will give us 72. Can you see? Now, 3 squared, that is 9. 3 raised to power 3, that is 27. And 3 raised to power 4, that is 81. And this is how we get all of these values, right? Now, when we have all of these values, what do we need to do? We need to add all of these. We need to add them together. And when we add all of this, when we add all of this together, it gives me 39. When we add all of this together, it gives me 100. When we add all of this together, it gives me 438. When we add all of this together, it gives me 2216. When we add all of this together, it gives me 185. When we add all of this together, it gives me 993. When we add all of this together, it gives me 5756. So then we can now say the summation of x, my sum of x is what? 39. My sum of y is what? 100. My sum of xy is what? 438. My sum of x square y, and that will give me 2216, right? Now, when we sum x squared, the sum of x squared, that will give us 185. The sum of x cubed, that will give us 993, and the sum of x raised to power 4, that gives us 5756. Now, when we have all of this value, it will permit me to rewrite my given equation. So from my equation 1, what do I have? I have it to be summation y equals what? Na plus what? Plus b summation x plus c summation x squared. You can see it is very easy to memorize. What do we need next? Summation xy, right? So which is what? This one will now become a summation x plus what? B summation x squared plus c summation x cubed. So it's just as if you are using x to multiply the next equation, summation x squared. You can see y. This will become a summation x squared plus what? B summation x cubed plus c summation x raised to power 4. That's simple as that. So if I'm going to rewrite all of this now, this will now become, what is my EY? EY, that is summation of y, is 100. Can you see? Which is now equal to our n, that is the number of, how many numbers we have as our data? We have 10 of them. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our n is 10. Can you see? Our n is 10. Our n is 10. So our n is 10. So let's write it. Our n is 10. So here we are going to be having 10a, can you see, plus, what is summation of x? What's our summation of x? Our summation of x is 39. So it will now become 39b plus, what is our summation of x squared? Our summation of x squared is 185. So it will become 185. You already know how it is going to look like. We need summation of xy. What is our summation of xy? Our summation of xy is 438. 438 is equal to a. That is summation of x. What is summation of x? That is 39. This will become 39a plus 185b plus. So our summation of x cube is what? 993. So we have 9936. Can you see? So we move on to the next one. Summation of x square y. X square y. That is giving us 2216, which will be equal to the summation of x square. The summation of x square is 185. So we have it to be 185 585A plus 993B plus 57, that is summation of x raised to the power 4, 5756C. So you can say that this is three equation in three variable. This is equation 1, this is equation 2, this is equation 3. Three equation in three variables. So when we solve this, at the end of the day, when we solve them simultaneously, we are going to be having our value of A. When we solve it correctly, our value of A will be 0.2709. Our value of B will be what? Our value of B will be 3.8948. 3.8948. Our value of C will be equals to minus 0.2952. Minus 0.2952. So having all of this, we are going to plug them back into our given equation. Don't forget that our given equation is what? Y equals to A plus bx plus 6x squared, right? Very good. So let's plug it in. So what do we have? We have it to be what? Our y will be what? 0.2709 plus what is our b? 3.8948x. Can you see? Minus 0.2952x squared. And this is giving us a quadratic equation vibe. So this is the required equation. So thank you very much for staying tuned for today's class. I am very happy that we have actually learned something today. And I am wishing you good luck and success in everything we do. Till we meet next time. Thank you. Bye.